Hello everyone. As we mentioned last time, today it's going to be a hands-on session in which we're going to use the Socio-Technical security modeling tool, that is the support tool for the Socio-Technical security modeling language, which we saw last time. So here is an outline of the talk we're going to have today in this tutorial about the tool. At first, of course, we're going to install the tool. I guess everybody brought their laptops, right? Okay. And during this tutorial, we're going to use a running example that gives a scenario from a case study we're working on, and which we'll use to model with the tool. And for starter, we're going to show how we can create a diagram and then continue using the tool by modeling our running example. So at first, for those of you who haven't already installed the tool, please go to this website, to this page, and download the tool version that is suitable for your machine and your operating system. You have the different links to download the suitable version of the tool. And the installation is as easy as extracting the archive2 folder and executing the STS tool binaries. Okay. So I'm going to wait couple of minutes for you to get the tool, and when you're ready, we can continue. Okay, you get it already installed. Then we can continue. As I said, we're going to use a scenario from a case study we're working on that is an example of a government case study on lot searching that describes a scenario in which the Department of Urban Planning wants to build an application which integrates the existing back office system with the available commercial services operating in the territory to facilitate the interaction of involved parties when searching for a lot. There are different parties involved in this scenario. The first one being the lot owner, which is the one that wants to sell a lot. The lot owner is the one that is responsible for defining the location of the lot to be sold. And in our scenario, it's a science, so it relies on a real estate agency to create the lot record, which contains all the details about the lot. The real estate agency, on the other hand, is the one responsible for not only creating the lot record, but also publishing it together with additional legal information that arise from the legal framework on about building terms on the given lot. The Ministry of Law actually is the end responsible for publishing the accompanying law on building terms for the lot. So the real estate agency would need to get this legal information from the Ministry of Law. Whenever we have selling and buying of a particular lot, of course, there is also an interested party, so the one that is searching for a lot and wants to acquire a lot. So the interested party would access the DOUP application to invoke the various services offered by the different real estate agencies. Generally, it would use the application by defining a trustworthiness level to allow only trusted real estate agencies to contact the interested parties. So this is a way of filtering that no untrusted real estate agencies would contact the interested party. So in this way, it sets a criteria to search for real estate agencies that would provide trustworthy services, but also similarly, it sets a criteria to search also solicitor, that is basically an attorney that would help with all the legal issues building, for instance, the lot, as well as a civil engineer. Both of them are assigned to assess the conditions of the lot and to act on behalf of the interested party so that the lot info is available for evaluation. The aggregated RIA service defines a list of trusted sources to be used to search for candidate lots. So it collects candidate lots from trusted parties and then ranks them to visualize to the user a ranked trusted list of sources. The Chambers is an end that provides a list of credible professionals, such as, for instance, the civil engineer and the solicitor. So as you see, we have a number of participants in this scenario which would interact with one another to get things done. So we'll start with creating the model for this EGOV scenario, and creating a new diagram is as easy as this. I'm going to switch from the presentation to the tool so that we will follow step by step the modeling activities that we perform to build the model for this scenario, and you can see live how we'll use the tool. Okay, so if you've already opened the tool, here I've already created the model for the EGOV scenario, but we're going to do it step by step together. So let us create a new diagram. So go to Files, New Diagram, or you could use directly the icon here in the menu. Select where you want to save the diagram. Give a name to the diagram and finish. So in this way, we've created a new diagram. This is the tool. Here we have the drawing canvas. Here on the right is the palette in which we have the different elements such as agent, role, goal, document, and event. And below we have all the relations which are categorized depending on whether they are relationships between actors or within an actor's scope, or between actors and goals, or different elements. So we've created the diagram, the empty diagram, and we will start with the modeling, following the modeling steps that we introduced in the STSML modeling method last time. So at first we are gonna start with modeling the social view. So going back to the tool, make sure you're on the social view. By default, the tool positions you in the social view. Using the tabs here, you could switch from one view to another, and the highlighted tab shows in which view you are. Moreover, in each view, the palette changes, showing only the elements that you'd need to use in that particular view. We will see this also when we go to each of the views. Okay, so once positioned in the social view, at first we are going to draw the identified roles and agents. So identify which are the stakeholders that are operating and interacting with one another in the e-government scenario. I've already identified here the actors in this scenario, and as you see we have roles and agents. Roles that are used to identify generic actors when we do not know which are the actual participants at design time, whereas agents refer to, let's say, more concrete entities, and when we do model them in our scenarios, it means that these are agents that we already know to exist when the models are being built. Such as, for instance, the DOUP application, because it is one particular application that is to be created, the aggregated REA, the Ministry of Law, because there is only one Ministry of Law in operating, say, in a territory, in a state, and on the other hand, roles are more as containers, which are, you could think of them as classes that have instances at runtime, so they can be instantiated by agents. So lot owner could be anyone, it could be me, it could be Paolo or you. So me or Paolo or one of you would be the agent that would instantiate this role at runtime. So now let's try to draw this actors we have identified in the tool. In order to draw the roles, you just need to click on the role element and then just release the mouse button when you're on the canvas, and then assign a name to this role element, say lot owner. Similarly for the other ones, interested party. The real estate agency is also role, because there could be many real estate agencies that are gonna register into this application to be contacted by the different lot owners or interested parties. We have Ministry of Law, the aggregated REA, and solicitor, and civil engineer, in the chambers. Guess this is all. Let's check. Okay, so now we need to represent also the DOUP application itself and the map service provider. The DOUP application, as we said, is an Now I'm trying to give the full name to this agent, that would be Department of Urban Planning, But as you see, I continue to type but cannot, and this is because in the tool we have set a constraint on the number of characters one can use to assign names to the elements when modeling with the tool. So in case you want to give longer names, but this restriction does not allow you, then use the Properties tab below here and provide a longer description for the assigned element, so that you could complete this description in case the name is not representative enough. And also you could do this for all the other elements, being these roles or agents, and provide more description on them, what is the mission or the purpose of this given role. Similarly, for the agents, there are a number of fields. Depending on the information that you have, you could fill in these properties for more complete modeling and for more detailed diagram. Okay, so we need also the map service provider, and with this we have represented all the actors in our scenario. Now, okay, so even here I emphasize that you need to use the properties to provide more details about the actors in the diagram. In the second step of our modeling method, we need to identify the assets that actors have and their interactions. So we will start with the lot owner and consider what are the assets that the lot owner has, and what are the interactions this role has with other roles. So we'll go back to the tool and start with the lot owner. Typically, the lot owner wants to sell a lot, so his objective, which is represented in terms of goals, is to have a lot sold. And in order to sell the lot, he or she could sell the lot either privately or sell the lot via an agency, via a real estate agency. And given that these are alternative options to having the lot sold, this objective is considered to be or decomposed into lot sold privately and lot sold via agency. So to represent this, we will take the or relationship, starting from the root, the father goal, to the child goal, and we have one side of the or decomposition being created, and similarly we will do for the other sub goal. In this way we have the or decomposition tree created for lot sold. Now, since in this scenario we know that the lot owner will rely on real estate agency to have the lot sold, we are going to refine the achievement of lot sold via agency. So what does the lot owner need to do in order to have the lot sold by an agency? At first, a lot record needs to be created, and then lot info needs to be provided, and a lot location needs to be defined, and finally the lot owner needs to specify also what is the price that he wants the lot to be sold, and then approve this price. So let's say lot price approved. These are basically, in a nutshell, the various objectives that need to be accomplished in order for the lot to be sold by an agency. Therefore, these indicate what is the process to sell the lot by an agency. So we would use an end-decomposition relationship starting from the father goal lot sold by agency to the individual sub-goals, similarly to as we did for the OR decomposition. Now the tool performs some live checks whenever we are drawing the diagram. So for instance, if we wanted to draw an OR decomposition starting from this and decomposed goal, as you see there is the sign that does not allow us, whereas if we went to this other goal that is not connected to anyone, we could. And also here it would be possible towards, but not towards any of the sub goals that are here. So the tool also helps us in building correct and valid models. So let's complete the decomposition. Basically, this is tree, and now save. So let's also check here. Basically, the lot is created, and when the information about lot is provided, then a document containing lot info is created. Therefore, we represent this as by means of a produce relationship. So similarly, we take the produce relationship. As you see, the tooltip also helps us into knowing in which direction the relation goes, from which element to which element. So you can see produce starts from one goal towards a document. So when lot info is provided, the lot info is created. Moreover, in order to participate into this interaction, the lot owner also needs to provide personal information. Owner personal information, okay. Okay, and as we said, the lot owner is the one that is responsible for approving the price and defining the lot location. And for this, it also has the capability to achieve these goals. In order to define that one actor has the capability to achieve his own goals, we can specify capability by right-clicking over the goal and selecting capability. In this moment, the stick is being created here, And similarly, we do so right click and capability, and we have this text being created showing that the actor has the capability to achieve these goals. As we said, the lot owner relies on the real estate agency to have the lot record created. So in order to represent this, we will draw a delegation from the lot owner to the real estate agency for creating the lot record. So similarly to drawing the other relations, we will click on the delegate relation, and in order to create a delegate relation, we will go over the goal that the actor wants to delegate and drag towards the delegatee and release. In this moment, the goal delegation relationship is created. We can adjust this position by clicking on the relationship and then moving it to a position in which there are no overlaps. If we look inside the real estate agency, we see that the goal lot record created is also drawn here, and the tool uses a slightly darker shade of green to distinguish between own goals and delegated goals. So for now we have represented the assets for lot owner and the interactions it has with the real estate agency. In order for the real estate agency to create the lot record, it also needs to have information about the lot. So not only the lot owner needs to rely on the real estate agency by delegating the goal lot record created, it also needs to provide information to the real estate agency, and it does so by providing the document lot info. So we selected the relation provide from the palette. We go over the document that we want to provide and drag the relation towards the providee and release. This will create the document provision relation. And similarly to goal delegation, we can move it to a position where there are no overlappings. Okay. So again, here we emphasize the maximum length of 25 characters and the need to use the properties to add further details. Now, in order to consider what are the assets for the real estate agency, the step 1.2 of our modeling method is an iterative one. So similarly to what we did for a lot owner, we will consider also for the real estate agencies. So the question we pose is, how can the delegatee achieve the delegated goal? So we will see more details about the real estate agency, how it can achieve lot record created. It needs to add the location map. Also, creating the lot record requires publishing the lot record and adding the legal information that needs the legal framework provided by the Ministry of Law. and the location map to be added is provided by some map service provider. So now we're gonna go and build the model for the real estate agency. So the real estate agency needs lot info to have the lot record created. So we will draw a need relationship from this goal to this document. So by releasing the relationship starting from the goal to the document, and represent how the real estate agency achieves this goal. So lot record published location map added, and we can add some more description here. Location map added as provided by the map provider. Okay, this is just to give you an idea of how to use the description, but the description could be more detailed and more precise according to the information that we have. And also we have the legal info added. And since these are all goals that need to be achieved in order for lot record to be created, again we use an anti-composition to represent this process, similarly to what we did for lot sold via agency in lot owner. Once we have captured these initial actors, their sets and interactions, the third step of our modeling method requires expressing security needs. So expressing expectations with respect to security that actors have towards actors they interact with. So in this situation, we have represented the interaction between the lot owner and real estate agency, and we will consider what are the security needs that are expressed. So for instance, the lot owner might require the real estate agency no redelegation of the lot record created. So the lot owner requires that only the real estate agency takes care of achieving this goal. So this goal and neither of its sub-goals should be redelegated to some other actor. And another security need expressed by the lot owner is that availability. Since it is relying on the real estate agency, it wants the real estate agency to provide a minimum availability level for this goal. So going back to the tool, we can express security needs of our actors' interactions by selecting the interaction, in this case the goal delegation, and in order to specify the security need, right-click over the goal. Then we'll have this drop-down list in which we can select security needs. We have the complete list of security needs that are can be expressed over goal delegations. And as we said, the lot owner specifies a no delegation security needs, so we can select no delegation. As you see, at the moment that we have selected one security need, there is this padlock being created within the goal, and if we double click over it, we'll see that there is this label, this rectangle colored label shown below the goal to explicitly specify what is the security need that has been expressed over this delegation. The security need for node delegation is particular because, apart from the label, it also graphically gives us a hint that the delegation should end here and not continue to any other actor for this goal, because the continuous arrow line is transformed into a dashed one. By double-clicking again on the padlock, the rectangle, the label disappears, but we still know that there are security needs expressed. As we said, the lot owner also requires a given level of availability. So similarly to the specification of node delegation, we again right-click over the goal and select availability. For availability, in order to, and now we can see two labels right below the goal delegation. In order to specify availability, we have to go in the Properties tab and specify the minimum availability level required for this goal. So let's say in this case it's 85%, and immediately the security needs field is updated into availability 85%, showing the percentage, the minimum availability level required for this goal. Okay. Apart from specifying security needs over goal delegations, we can specify security needs also over document provisions. Say, for instance, and similarly to goal delegations, again, we right-click over the document, and from the security needs, select the one that we want to specify. Say the real estate agency is worried about the integrity of the information regarding the lot, so it may require the lot owner to ensure the integrity of the information about the lot. And similarly, we have the padlock being created and the label being shown when we double click on the padlock, and hidden again when we double click again. In this way, we have expressed the security needs for this first interaction identified, and we would need to continue for all the other parties. Similarly, as we did for the lot owner, so we'd consider the interested party having this goal model. So we say the interested party wants to acquire a lot, and in order to acquire the lot, it will first search for a lot and then evaluate this lot by assessing its status, select the list of trusted real estate agencies, and select a solicitor and a civil engineer. In order to assess the status for a lot, it will first need to select a lot and then assess the information it has about this lot. When searching and selecting for lots, it will need the list of best lots, and in order to select a given solicitor and a given civil engineer, it needs the list of credible solicitors and credible engineers. And again, even for the other parties, we would identify the interactions they have with other actors. So, for instance, the interested party relies on the DOUP application to select trusted real estate agencies and over this interaction, it specifies trustworthiness level for the given real estate agency. So the security need that is being expressed is that of trustworthiness, and also within the interested party, since the interested party is the one responsible for assigning and selecting a given solicitor and civil engineer, we define binding of duty, security need, which is expressed by this relation here. And now we will show on the tool how these are expressed. As I said, since I've already, you can continue by modeling this scenario, working on the created file. I will show you by performing changes over the already created model. So the interested party has these assets. It needs these documents and has to achieve these goals in order to acquire the lot. When relying on the DOUP application to have trusted real estate agencies, it can specify a trustworthiness level. So let us remove this. Removing is similar to assigning a security need, so it's enough to check or uncheck the desired security need. So we can now specify it back again by right-clicking security needs and trustworthiness. And the padlock is being created here. And we could show the label by double-clicking. And we assign the trustworthiness level over the Properties tab. We could say that the interested party requires a minimum trustworthiness level of 9. So the precondition for having trusted real estate agencies is that their trustworthiness level should be above this minimum trustworthiness level set by the interested party. Similarly, we would go on and build the models for all the other interacting actors. So, since the actors interact through the DOUP application, the interested party would rely on this application also to search the lot, and would get back from the DOUP application the list of credible solicitors and credible civil engineers and the list of best lots. That is why these documents here within the interested party scope are shown in slightly darker gray shade to distinguish from the documents that are first being created and possessed by a given actor, such as, for instance, the list of credible civil engineers being created by the credible civil engineers provided by the chambers, and similarly for the solicitors. These are provided to the DOUP application, which then distributes them to the interested parties. Okay, so we'll now go back to the presentation. As you can see, the modeling process is an iterative one. The steps in each phase are iterative, so identifying the assets and interactions for each of the identified agents and roles is iterative, so we will need to continue till all actor models are built and all their interactions are identified together with all the security needs. So we need to capture all the different security needs specified by the actors. And in our case, we need to ask each time which are the remaining actors and how can they achieve their goals, their own goals together with the delegated goals. What are the documents that they manipulate while achieving their goals, and what are the actors they rely upon. This helps us identify the different goal delegations and document provisions between actors. So if we consider the next iteration of the modeling, we still have the DOUP application, the aggregated RIA, the Ministry of Law, the Chambers, and the solicitor. So this would be how the model would look like. And we could look this also live on the tool. Due to time restrictions, we are not modeling this live altogether, but I wanted to give you a hint on how to continue to build the model. So the DOP application has the objective of helping citizens in acquiring and selling lots, and for this it provides the list of credible civil engineers, the list of credible solicitors, it selects trusted real estate agencies by using the aggregated real estate agency service. It helps citizens by searching for the lot, and also for this it relies on the aggregated RIA service that finds the list of trusted sources and ranks the lots according to their to the trust and the source they come from. And moreover, the lot owner needs to be registered, as well as the interested party needs to be registered in order to use the DOUP application. So for instance, the lot owner has to provide his personal information. And similarly, we would have to consider all the different actors. Say, for instance, the Ministry of Law is the one responsible for issuing the legal framework, and while achieving this goal, it produces the legal framework, which then is provided to the real estate agency and is used to add the legal info for the lot. In this way, we have represented actors with their assets and interactions and have captured all the security needs for the eGov scenario. Lastly, in order to conclude the first phase of the modeling method, modeling the social view, we need to represent also the threats that might threaten actors' assets. So we need to ask which are the goals and documents of actors that are being threatened, and represent these threats. So as we explained last time in the socio-technical security modeling language, threats can be specified over documents or goals. Here in the eGov scenario, We consider, for instance, an event unavailable to threaten the list of credible civil engineers. In order to, I'm gonna delete this event to show you how we create events and represent threats in the social view. We will use the element event from the palette, and similarly to the creation of other elements, an event is created by clicking on the event, dragging it to the canvas, and releasing it here. Okay, the reason that the event was not being created is that it does not pertain to any actor, therefore we need to be careful that it does not intersect with any of the actor's scope. So the event is being created and we can rename it by double-clicking on the default element name, say unavailable, and this event threatens the document credible engineer. In order to represent this, we will draw the threatened relationship starting from the event toward the asset that it threatens. As you can see, the tool also performs a live check because threats are only drawn from an event to an asset, so we cannot draw it vice versa. So starting from the event, the threatened relationship is drawn. And similarly, we have represented another event, not found, threatening the original credible civil engineers over their creation from the chambers. Moreover, another threat over the goal credible solicitors provided defines that this goal could be unreached, and similarly we have expressed another threat not achieved, threatening the goal legal framework issued that will be accomplished by the Ministry of Law. And these are the threats, the events that threaten the various assets of the actors in our scenario. With this, we have completed the steps for modeling the social view, and this is how the social view looks like, with all the different actors, their interactions, the security needs, and the threats affecting the actors' assets. We'll now continue with the second phase to model the information view. And for this, we will switch views in the tool, going to the information view and identify what is the informational content of the documents that actors possess and operate with in the social view. So let's go back to the tool, and as I said at first, in order to switch from one view to the other, it's enough that we select switch using the tabs here. The particularity of the multi-view modeling is that we can see this better from this example that we created in the beginning. When we switch to the social, from the social view to the information view, we see that all the different actors that we've created in the social view are also present here in the information view. That means that all the elements of the actors that we've created there are also preserved here. However, the views are independent in the sense that if we move one element here, the position in the other view is preserved as it was originally in this view. However, if we delete a given element from one view, it will also be deleted also from the other view. So as you see, we do not have the chambers anymore here. And once it is created, if we create it, it will be also created in the information view and authorization view as well. So it is in this way that we can create the complete model for a given scenario, but still focusing on different perspectives at a time when moving from view to view. As I said, in the information view, we want to capture the informational content of the documents that that actors have and exchange with one another in the social view. So we consider, for instance, just to give you an idea here before showing you the complete information view of this scenario, lot owner has lot info and his own personal info. So in order to represent what is the information, after talking with the lot owner, we have identified that the lot owner has ID document number. So this is an information that is represented by the lot owner personal information. For this, once representing this information, in order to connect it to the document that represents or makes tangible this information, we will draw a tangible by relationship starting from the information towards the document. In this way, we can connect information with documents. But importantly, in the information view, we do not only represent what information is contained in which documents, but also who are the owners of information. So here we consider lot owner to be the owner of his own ID document number, and we will draw a known relationship starting from lot owner towards the information that she wants. And we have this double headed arrow representing the ownership relation starting from the actor towards the information. Similarly, we can represent different informations. So we consider the lot owner to have also a VAT number, and he is again the owner of this information, and this information is again represented into his personal information. Therefore, we draw tangible by relationship. And with respect to lot info, we consider lot geolocation to be made tangible by lot info, and similarly other details that are part of the information. So lot info details are also made tangible by lot info. And this information is also owned by the lot owner. Apart from this, in the information view, we also represent the structure of information. We consider, for instance, in this case, that the lot geographical location is part of all the different details that are provided by the lot. So we can draw a part of relationship from the information to the bigger information piece. So to express that the lot geographical location is part of lot info details. And similarly, part of relationships can be drawn from document to document to capture the structure of documents. So now I'm moving back to the already drawn information view for the scenario. We have represented this first part. Similarly, we can represent all the information about documents is actually preserved from the social view. Here we just need to represent the information and connect it to the document. So from the social view, map, as we can see, the map service provider produces map document, and this is preserved also in the information view, and we represent that the lot geolocation is made tangible by this document. Similarly, legal info is owned by the Ministry of Law and is made tangible by legal information. The chambers own the list of credible civil engineers in this case, which is made tangible by the document credible engineers. We here give an example of structure of documents. Trusted sources are composed of trusted real estate agencies and best lots. Therefore, trusted real estate agencies and best lots are considered to be part of trusted sources. And in this way, we have completed the information view for this scenario. We consider that the interested party, the solicitor, do not have any own documents for simplicity here, and therefore we do not represent any information related to these actors. But we concentrate on the rest of the stakeholders. So, as shown directly on the tool, this would be the information view for the eGov scenario. Now, we need to capture what are the permissions that actors grant to one another with respect to the information they own or have authority to manipulate, to perform operations with, towards other actors that might need to perform operations over this information. And for this, we need to switch to the third view, the authorization view, again using the Views tab, and starting from information owners, we ask the question for each authorization relationship that we want to draw. We consider, is the authority to transfer authorizations granted? What is the authorization granted for? So what are the allowed operations? For which information? And is the scope limited to any goal, or is it that the authorization is granted for any scope? We'll draw authorizations directly in the tool. So first, switching to the authorization view, here is the complete authorization view for the eGov scenario. I'm going to use the small example to show you how we can model the authorization view, considering the first two actors of this. We can rearrange the positions of the elements for better visualization. And let's consider starting from the information owner. We can draw an authorization relationship from one role to another, and when we release the mouse button when approaching the second actor, this relationship, the authorization relationship, is drawn. It contains three slots: the one for specifying the allowed operations, the one for the information. As you can see, the tool gives a hint to the designer saying double click to add information. We consider that the lot owner will authorize the real estate agency to use, produce, and distribute details about the various information concerning the lot and the geographical location in order to create the lot record. So we will double click here to select the information. As you can see, there is this pop-up window that provides the list of different information. So we will select lot info details and lot geolocation. And once this information is selected, when clicking OK, they will be shown here. We consider that the lot owner provides transferable authorization to the real estate agency. Therefore, the line is continuous. Otherwise, we can specify that the authority is not transferable by simply right-clicking over the authorization relationship and unticking transferability. This will make the authorization arrow line from continuous to dashed, as you can notice, and we will go back by again right-clicking and selecting transferability, because this is a type of authorization lot owner is providing. And the authorization specifies that the real estate agency can use, produce, and distribute this information, but it cannot do this for any purpose, but strictly to create the lot record. So this goal is selected from the list of goals of real estate agency, and once selected, the third slot is being filled. Okay, I'm going back to the full model. Similarly, we consider all the different authorization relationships of the different information owners. So for instance, Ministry of Law owns legal info, and it authorizes the real estate agency to use this legal info in order to add it to the lot record created, but it does not provide a transferable authorization. So the real estate agency cannot transfer authorizations about legal info to any other parties. And apart from, similarly, it also, the Ministry of Law itself authorizes the solicitor to use legal info for providing legal framework. Then, starting from eligible actors such as the solicitor, we draw authorizations, such as, for instance, that of solicitor authorizing the DOUP application to use and distribute legal info for helping citizens. And in the same spirit, we continue with the rest of the authorizations, either from information owners or from other parties. And as we have mentioned last time in the tutorial about the modeling language, in the authorization view, we can implicitly capture security needs that actors have depending on the type of authorization they grant. So whenever an operation is not granted, a security need for not performing the operation is required. That means, for instance, in this case, when usage and distribution are allowed, then security needs for non-modification and non-production of legal information are required by the solicitor to the DOUP application. And also, whenever the scope is limited, such as, for instance, in this case, within the scope of the goal citizens helped, this requires that the DOUP application can use and distribute this information only for the scope, but not for any other purposes. In the same way, all the different actors express their expectations regarding security by specifying the type of authorization they grant to their interacting parties. And this is the complete authorization view for our eGov scenario. Again, all the modeling process is iterative. All the different views can be further refined depending on the information the designer has. Also, changes could occur. So changes in one view would have effects on the other views. And basically the termination criteria would always be posing the question if we captured all important interconnections and if we were able to express all the security needs that the stakeholders have. And also, when building the models, it is important that you use the properties to better describe this model and justify the modeling that you have performed. With this, we conclude the first part of the modeling method that involves the three phases for the modeling activities from one view to the other. I now will show you how we can perform automated reasoning and analysis using the tool. As we saw last time, there are three different analyses that are supported currently by the tool. The first one, performing consistency checks. Apart from the live checks that one can, that the tool helps designers when drawing the models, there are others that cannot be performed live since we do not know the order of the modeling operations the designer performs. Therefore, we need to perform a post check and to verify that the model follows the semantics of the modeling language. So, in order to perform consistency analysis, we'll go to the consistency analysis tab that is represented by this C capital letter here in green, And when we'll run this analysis, a pop-up window will show enumerating all the different checks that are performed during this analysis. So for instance, checking that the diagram is not empty, otherwise there is no reason to launch this analysis, and then verifying different relations are drawn in compliance with the semantics of the language. And it will show whether the check did not find any errors, or if it found any problems by specifying a warning, which is basically a not so good practice of modeling, but it's still not an error. But finally the check could identify an error, and in that case the error needs for sure to be solved before continuing with the rest of analysis. But let's go to the tool and run the analysis over our model. So as I said, let's go to the consistency tab, click on it, and this pop-up window shows start analysis, and the checks are being executed, and we see that the analysis identified two warnings, one specifying that there is one information without an ownership relation being specified. So for being complete in our models, it would be the case that we need to specify information ownership for all the different pieces of information. Otherwise, we cannot know whether there are any security needs not expressed. The results of the analysis can be shown by the analysis tab, and as you see, there is this list of results that are also shown in the diagram. In order to focus on one problem at a time, we could hide all the results, and we can simply unhide one problem that we want to identify. So for instance, in this case, information list of selected lot is not has no owner. So the analysis, the consistency analysis, tells us that there is no ownership relationship specified towards this information from any actor. And by talking to the stakeholders, we could verify whether this is okay or not, whether this information is not owned by any actor, or if there is an owner, we could draw the ownership relation. And similarly for the rest of the checks. When going over one of these, the tool positions and shows the problem in the diagram, visualizing in yellow in this case for the warning. Okay, after the consistency analysis, we can the second type of analysis that is supported by the tool is the security analysis, for which we need to go to the second tab, the security analysis tab. And the purpose of this analysis is to verify whether the different security needs that we have captured throughout the modeling can be satisfied or are violated by in the given diagram. So in this model that we've built, we want to verify whether the different security needs are violated or not. And the checks of security analysis actually go and verify whether there are any violations, and if there is a violation encountered, then an error is identified. Otherwise, if there are no violations of security needs, then no errors are found. Let's go to the tool and run the security analysis by going to the second tab. Start the analysis. The security analysis requires that the model is consistent. Therefore, even though we might have skipped running the consistency analysis, the security analysis itself runs the consistency analysis by default. And since no errors were identified, it then proceeds with the rest of the checks. And as we see here, there are a number of errors being identified by the security analysis, which we can look in more detail in the analysis tab. So if we go over security analysis, we see that there are a number of red crosses that specify problems. That means these are errors, and in yellow we have warnings, which mean that there are possible violations of security needs. We can similarly hide all results so that all the visualizations of the problems are cleared by the diagram, by the graphical model, and then we can just unhide one result so that we can identify a violation. So this violation tells us that real estate agency makes an unauthorized redelegation of goal location map added. And if we check the description, we can realize why there is this violation. The reason is that lot owner here has specified a no delegation security need over the delegation of lot record created when delegating it to the real estate agency, and yet the real estate agency is redelegating goal location map added to map service provider. When the specification of a no delegation security need over a goal requires that not only the goal is not redelegated, but also none of its sub-goals can be redelegated. That's why the analysis finds an error. Okay, let's now look at another problem. So, okay, the analysis also has identified that there is an unauthorized authorization starting from real estate agency towards aggregated REA. The reason is that the real estate agency is not granted transferability, the authority to further transfer rights to other actors, but still the real estate agency is authorizing the aggregated REA with respect to legal info. And this is captured by the analysis. Also, another problem is identified when solicitor is authorizing the DRUP application to use and distribute legal info when the Ministry of Law is only granting usage but not distribution. So the solicitor is making an unauthorized authorization of distribution. And in the same way, we can identify different problems in our model, such as, for instance, that of the map service provider making an unauthorized production of information lot geographical location, given that this information is owned by lot owner and no authority is given to the map service provider to produce this information in any form. So to resolve this issue, either the lot owner should grant the authorization to the map service provider, or the map service provider should not produce this information without having the authorization. And in this way, we have seen the different problems identified by the security analysis. Finally, the tool allows also to perform automated reasoning over the propagation of the threats that we have specified over actors' sets. So we have specified threats over actors' goals and documents, and by going to the threat analysis tab, which is the third tab in the analysis tab, we can see what is the impact of specifying a given threat over goal towards the rest of assets being related to this one goal. So for instance, when we have the event unreached threatening credible solicitor provided, since this goal is producing a new document, also this document would be a threat. So it's considered to be threatened. And if this document is being provided to some other actor, also that other the document of that other actor would be threatened, since the actor might as well not be provided with this document if its creation is a threat. Similarly, when we have a threat being specified over a document, if this document is needed by some goal, then the goal itself is considered to be threatened. And if a given goal is threatened, then also its root goal will be threatened, especially in the case of an end decomposition. Let's go back to the tool and run the threat analysis by going to the threat analysis tab. The threat analysis simply runs one task because it wants to perform only threat propagation. Therefore, it will identify the impact of an event. So for instance, the event, let's hide all the results again. And if I see, for instance, the event unavail in the diagram, what is the impact it has? Since this threat threatens credible civil engineers, it also threatens C is selected, and it also threatens lot acquired. But this is the whole impact it has on the diagram. Now let's check another one. We have the threat not achieved of the goal legal framework issued, and the impact of this threat is slightly bigger because it is creating a new document, legal framework, which is then provided to the real estate agency. So if this document is threatened, that also the goal that needs this document is threatened, and also the further goal of this goal is threatened. And again, the same document is being provided also to the solicitor, which will help the interested party. And this document is needed to provide the legal framework. Therefore, also the goal of this actor is threatened. Okay. Once we have performed the modeling and have run all the different analysis of our model, making sure that there are no problems and we have resolved the issues, we can derive the set of security requirements and generate the security requirements document. So in the tool, we can see the security requirements that are being generated and are expressed in this tabular form. The security requirements can be, as you see here, they are grouped by the actor that is responsible to satisfy the security requirement. We then represent what the requirement per se is, and finally the requester of this requirement. We could order the requirements by the requirement type, for instance. So we have a changing combination which specifies a binding of duty security need between two goals. And the requester here is shown with this hyphen, since these are considered as normative requirements, so requirements requested by the organization or perhaps the legal framework in place, and all agents need to satisfy the security need. We have availability, that is a requirement for requested by a lot owner to the real estate agency that the availability of lot record created is 85%. For each security requirement, we have not only these three main fields, but also a more detailed description that represents the textual security requirement, specifying in this case that the real estate agency commits to lot owner that will ensure 85% of availability for goal lot record created. In the same way, for instance, a need to know requirement requested by the lot owner requiring the DRP application, need to know of information ID card number and that number in the scope of goal lot owner register. So this requirement specifies that this information is only used for registering the lot owner and for no other reasons. And similarly, for the rest of security needs that have been specified, we have the corresponding security requirement being generated here in this table. And we can finally generate the security requirements document by going to diagram and create requirements document. We can give an adequate title to our security requirements document. And the author name, as well as the institution, and then we could browse to assign where we want to save the requirements document. Let's say and then the tool allows us to select. We can customize whether we want to show details about a given view or not. In this case, I'm letting everything be produced in the security requirements document, but one could use this document to get more details about the model, so it could focus on one information or on a particular view and so on. So it could omit or leave all the information. By clicking finish, we will have the requirements document being generated. Let's wait for a minute till it is generated. Okay. And the document is automatically opened. We can see that there is this front page with the title, the author, the institution, the date of creation, the table of content of this document, an introduction giving what is the purpose of this document, and then details of the different views, providing the image for each view, and then details about stakeholders both in textual and tabular form, and in the same way for all the different interactions and assets. So we have the same for all the views, with the information view, in which we model ownership, and we have details of that. And we have the list of requirements being described both in textual and summarized in tabular form, being grouped by the responsible that needs to satisfy the security requirements, specifying the requirement and the requester, and also the textual description of the security requirement to be satisfied. Finally, the report, the security requirements document, also provides the details of the analysis for all three types of analysis: consistency, security, and threat analysis. And in appendix, it provides the bigger images for the three different views and details about the different analysis currently supported by the tool. So as we saw in the tool, this is the list of security requirements and the generated security requirements document. So thank you and hope you enjoyed the tutorial. See you next time.